Greetings to all. Myself K. Brian Kumar. Currently, I am pursuing computer science in artificial intelligence and machine learning in SRIT College. Now, I am tell about backtracking, a general problem-solving technique. Backtracking is a powerful problem-solving technique that systematically explores all possible solutions by building candidate solution incrementally. Introduction to backtracking. It involves making choices at each step, exploring all possible paths and backtracking if a choice leads to a dead end. First point, systematic search, explore all potential solutions one by one. Second point, incremental construction, build solutions step by step, adding components. Third point, backtracking mechanism, rewind to previous choice if dead end is reached. Here the flowchart indicates the subtracting tenant regarding to the example on the sequence of backtracking. When to use backtracking? Backtracking is often used when solving problem involving constraints and decision making. Constraint satisfaction problems, finding solutions that satisfy specific conditions. Combinational optimization, finding the best solution from a set of possibilities. Such problems, exploring a space to find a specific target. Backtracking algorithm basics. Backtracking algorithm typically employ a recursive approach exploring each possible branch of the solution space. First one, start. Initial the solution state. Second one is recursive exploration. Explore each possible choice at the current level. Check for validity. Evaluate if the current choice is valid based on the constraint. Fourth one, back, backtrack. If a choice leads to dead end, backtrack to the previous level. Depth first search (DFS) approach. Backtracking algorithm often used to a depth first search (DFS) strategy, exploring one branch completely before moving the next. First one, start. Begin at the root of the search tree. Second one, explore branch. Traverse down a branch of the tree, making choices at each level. Third one, backtrack. If a choice leads to a dead end, return to the previous levels and try another branch. Fourth one, continue exploration. Repeat the process until all branches have been explored. Pruning and optimization. Pruning techniques can optimize backtracking algorithms by eliminating unnecessary branches from the search space. Constraint propagation. Proactively enforce constraints to reduce potential choices. Bounding functions estimate the potential of a branch to guide the search. Heuristic evaluation use knowledge about the problem to prioritize promising branches. Backtracking applications. Backtracking applications find numerous applications in diverse areas of computer science. Problem Sudoku. Its application is solving Sudoku puzzles in queens. Place n queens in n into n chessboard without attacking each other or colliding. Traveling salesman problem. It is also nothing. It is also nothing but called sales traveling salesperson problem. Finding the shortest route that visits all cities one and a route returns to starting city. Challenges and limitations. Challenges and limitations. Backtracking will powerful faces certain challenges and limitations. Time complexity. In worst case science scenarios, backtracking can have exponential time complexity. Memory use. Recursive calls can consume significant memory, especially for large problems. Problem suitability. Backtracking is not always the most efficient approach for all problems. Best practices for backtracking. Following best practices can enhance backtracking performance and efficiency. First one, optimize constraints. Efficiently enforce consents to reduce unnecessary exploration. Second point, use pruning techniques. Implement strategies to eliminate unproductive branches for the search space. We know very well about pruning techniques. There are several types of two types of pruning techniques. First one is pre-pruning and post pruning. uh, Pruning means removing the reducing the size of tree. And algorithm, choose third one is choose appropriate data structure. Select data structure that efficiently store and retrieve information. Conclusion and key takeaways. Backtracking provides a systematic approach to solving problem with constraints and choices. First one, exploration. Explore all possible solutions incrementally. Second one, backtracking mechanism. Rewind the previous choices if a dead is reached. Third one, optimization. Using pruning techniques and best practices to enhance performance. Key characteristics of backtracking. Backtracking systematically search for a solution by building candidates and abandons candidates as soon as it's determined they cannot lead to a valid solution. This technique reduces the search space and improves efficiency in problem solving. Limitations of backtracking. Backtracking can become inefficient for large problem space due to its depth first nature. It may require significant memory for storing the state of the search tree. Some problems may still be too complex for backtracking alone, necessitating hybrid approaches. Feel free to modify any part of this outline to better suit your presentation style or audience. Thank you.